Hello, my name is Torkel Klingberg. I'm professor in cognitive neuroscience at Karolinska Institute. And in this short lecture, I'm going to give an overview of attention and its links to working memory. So first of all, what is attention? Well, we're constantly surrounded by information and distractions. And we can only process a small part of this. And attention is a way to select the information that we want to process or attend to. And you can think of different types of attention. Sometimes we talk about level of arousal as a kind of attention. This is about if you go from being unconscious to drowsy, to alert, to hyper stressed. So it's a kind of general arousal or vigilance. But then it is also a process where we attend to a specific object or a specific position in space. Perhaps something novel occurs in the surroundings and our attention is drawn to that position. But you could also decide on what to focus on. Right now you're deciding to focus on me or the screen rather than something else in your surroundings. So both stimulus-driven attention and controlled attention, or top-down attention as it's also called, is a way to select a specific part of your surrounding that you're going to process information from. I'm going to give you an example of a task. So this is a very simple task. You raise your left hand if you see a dot to the left, you raise your right hand if you see a dot to the right. So when a dot appears like this, you raise your left hand. So this is an example of bottom-up attention. Something occurs in the surroundings and your attention is drawn to that position. But I can also tell you that there will be a 80% probability of the next cue occurring to the right. So keep your eyes focused in the middle of the screen, but put your attention to the right, because that's where a target probably will appear. So when you're doing that, you can see that you're focusing your attention to the right so that when a target appears there, you will be faster to respond, and you will also have a higher sensitivity to detect small changes in that position. You will be worse off detecting stimuli that appear in non-attended regions. And this kind of attention is often necessary for both long-term memory, and as we will see, it's partly the same thing as working memory. In meta-analysis such as this one, it is suggested that stimulus-driven attention and the top-down attention, they make use of different networks in the brain. It's a more ventral network for the stimulus-driven attention and a dorsal frontoparietal network for the top-down or the controlled attention. And if you're familiar with some of the cognitive neuroscience of the brain, you would recognize this dorsal frontoparietal network, because we see it activated also in visuospatial and other working memory tasks. So why would we see this similarity in neural networks in attention and working memory? Well, if we look at the details of an attention task and a working memory task, such as the delayed response task, we can see similarities in the details here. So in the delayed response task, you see a cue at a position, you keep information about that cue in working memory so that you can respond based on that information. And in this attention task that I showed, Posner's test of controlled attention, you will direct your attention to a specific location in space so that you will be faster to respond. But what's done here in the middle part, in the delay of the working memory task, as well as in the delay between a cue and a target appears, is very much the same. You retain information about a spatial position here. One way to put it is you need to remember what to focus on. And this similarity between attention and working memory can be seen also in studies where the same participants do either a working memory task or an attention task, such as this study here. The black regions here indicate similarities between attention and working memory. And we can see that those areas are in the interparietal cortex here, in the superior precentral sulcus, and in the dorsolateral prefrontal cortex. So one way to illustrate this is with a graph like this, showing that there is a large overlap between brain activity in directed attention and spatial working memory. And this can be seen both in psychological tasks and in neurophysiological mechanisms underlying attention and spatial working memory.